Hey everyone, thanks for joining us for the next session of our Learn Live 101 Security, Infrastructure Security, and Data Security Fundamentals. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our Code of Conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer. Our session is being recorded. It will be available to view on demand within 24 to 48 hours on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenter for today. Sarah, thanks so much for joining us.
Hello and hi everybody. Thanks for joining me. If you tried to join last week, sorry about the technical issues that we had. No, that was just one of those things. If you hopefully you've noticed we scheduled that for we're going to do 2 sessions next week to make up for it. So one at the same time and one a couple of days later. So we'll do that postponed one. Anyway, the good news is we don't really have to do this in order too much. So we will get into it. These next couple of episodes are a little bit shorter, so we might not even take 45 minutes, which is nice. But as usual, please ask questions as we go, and I'll try and answer them. And hello, Ravi, who's here from San Diego. I'm actually in Korea right now, so I keep being in different parts of the world whilst I do this as well. So this is what we're going to cover today. We're going to look at infrastructure security and data security. So we'll look at the sort of key concepts around that, what the kind of capabilities are, and we'll do the same with data security as well. As I said, I'm not sure we're going to go for 45 minutes. We'll see how we go. But if we go out on a bit of a tangent, maybe we will. I tend to do that. Maybe we'll still take all the time. And of course, as usual, I can read the comments. I do have enough screens in front of me today, so please do say hi and ask questions as we go. And yeah, let's get into it. So first up, infrastructure stuff. First of all, infrastructure, probably important to talk about what infrastructure is. So when we talk about infrastructure in the sense of security, we're talking about everything that underlies a system. So we could be talking a cloud platform, servers, routers and switches, all of that stuff all of the stuff in an IT environment that supports what we build on top, like applications and the things that generally users would interact with. And that stuff, although users might not interact directly with it, of course, it's also susceptible to attack. Attackers can attack any part of infrastructure. So it's important that we keep our infrastructure really, really secure. And what we often call that is security hygiene. Now, security hygiene actually can refer to everything, but I think it fits best in this infrastructure bit. And when we say security hygiene, this is just doing the basics right. So it's keeping software up to date, patching your servers, not using basic passwords, not resharing things. A lot of, as you can see, as we get through this series, I am starting to repeat myself a little bit because although I've separated all of these things into different topics, I mean, security it's not so clear cut. All of these things are interlinked and we do them across everything. So we really need to keep our infrastructure very, very secure. And security hygiene is very common sense. It's, as I said, it's things that I'm sure you already know about and that we've already discussed. However, it is also very security hygiene is hard to do well. It sounds easy, and sounds common sense, use complicated password, use multi-factor authentication, keep things up to date. But in reality, in a enterprise environment, it's actually quite hard to do well and consistently. And unfortunately, for attackers, we only need to get it wrong once for them to possibly be able to exploit that. Whereas they only need to we only need to get it wrong once for an attacker to do something bad, whereas we have to do it consistently right every time, and that's why it's hard. So we do something called security posture management. So one security posture is essentially how secure your environment is. You might have a good security posture. You might have a bad security posture. Of course, we want people to have good security postures. And so security posture management is where we're basically trying to manage and improve security posture to make it as good as we can, to reduce that likelihood, going back to when we were talking about risk, to reduce the likelihood that attackers will find something to exploit. So security posture management, again, isn't just one particular part of IT, it's everything. And it also includes people as well. As I said, all of these concepts do start to leak into each other a lot more as we get further into this. Security posture management is trying to get a view overall of how an organization's security posture looks. It's actually really hard. It's so hard to do. It sounds simple to be like, oh, hey, let's look at all of our assets. Let's look at everything we have IT-wise in our environment and all the people and the processes. How secure are we? Because that's often what like execs and leadership want to know. And it's a really difficult question to answer. So difficult. But security posture management is kind of the practice of trying to do that. So one of the things I talked about was patching. So we'll come back to security posture management. Remember that. We'll talk about it in the capabilities section. So patching, I'm sure most of you probably I'm sure pretty much everybody who is watching this or listening will have patched something, even if you didn't realize it. Patching is installing updates, whether that's software, can be hardware, firmware. Patching is important because we do patching for various different reasons, but it can be for feature updates, it can be to fix bugs, and it can also be, which is the most important in the context of this, is it's for security issues. So we talked about how when we find security vulnerabilities, they need to be patched, and before them there is 0 day. So patching in security context is to patch away security issues. Now, patching, again, if you've had a device, I'm sure you've seen, oh, we need to update your device. Do you want to install this update? And sometimes people are like, no, I don't want to install this update. It's too... I don't want to do it now. It's going to be, I don't have time for this. It's annoying, blah, 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 blah. Now, that is something that can be a problem, right? I'm sure anyone who's had a computer for probably like 10 years plus remembered when, like, say, Windows updates, we used to be able to just say, no, I don't want that update, I don't want that update, and we'd never turn off our machines so it wouldn't install the updates because we didn't want to have to wait to do the updates. But of course, from a security perspective, that is terrible. Now we do have tools to stop that nowadays, or we can we can enforce people doing patches, but certainly in your private life we don't have that. And I would encourage you to definitely, when you get an update push to whatever it is, please install it in a timely manner. I can't believe this was about 8 years ago now, but some of you might remember in 2017, I think it was, WannaCry. So WannaCry took down a lot of systems worldwide. That actually was a vulnerability that people were calling it a 0 day. It actually wasn't a 0 day. It came out later. It did have a patch that had been, it was a window. It was a Windows vulnerability. It actually did have a patch that had been released by Microsoft, but most people hadn't applied it. So when the baddies made malware that was exploiting this issue, it still spread worldwide very, very quickly because a lot of folks hadn't applied that patch that we'd issued in a timely manner. So that's a good example from a while ago. But as I said, patching is really important. Hardware stuff actually also needs hardware things also need patching. Hardware is much more difficult to patch because it's not software, and hardware runs something called firmware usually. Firmware is kind of something that sits in between software and the actual metal. It is not as easy to update firmware as software. Sometimes you can, sometimes you can't. And hardware vulnerabilities can't be patched really at all. So a really good example of this, of just an item that I'm sure you're all familiar with, is the Nintendo Switch. So the original Nintendo Switch that was manufactured for the first couple of years had a vulnerability in the graphics chip. So that's a hardware vulnerability. And if by exploiting it, and I actually did this on my Switch, so it does work, you could exploit a bug, a security bug in the chip, to basically take over the Switch and run whatever you wanted on it. Now, because it was hardware, there was no way to patch it. You can't patch a graphics chip. So for all the Switches that had already been manufactured and sold with that chip, they have that vulnerability forever. Whereas software, of course, we can push updates. Now, Nintendo did, I will say, and the manufacturer of the chip did update the chip and a couple of years later, and then started issuing Switches with the bug removed. But again, see, hardware much more difficult, so you have to test hardware. So someone asked in the chat, what is a zero-day vulnerability? A zero-day vulnerability is something that hasn't been patched yet, that has no patch, that has no remediation or patch. So we call it 0 day because it's new, there's no protection against it, it can be exploited. Another 0 day that was out there was Log4j a couple of years ago. There's not 0 days. People make a big fuss about 0 days. And of course, they are scary because the idea of having a security vulnerability that you can't patch is scary. But there's not as many of them out there as you might think. And the fact is that to create a 0 day and develop one and find a brand new exploitable thing is actually quite hard. And it takes a lot of resources. Whereas, so if we look at it from like an attacker perspective, if they're looking for return on, ROI, return on investment in their time, if you're not doing basic patching for stuff that we already know about, and you're you sharing passwords, etc., that's a much easier thing for them to exploit than bothering to go and create a 0 day. It's not that we shouldn't be mindful of them, but it's just important to put in perspective that they're probably not the top thing you should be worrying about. That, again, some people in security have different opinions on that, but that would be mine. Okay, the other thing I want to talk about from a hardware, so I've talked about servers, etc. But to be honest with you, most of us don't run on what we would call bare metal servers and put systems on top anymore. Generally, we're putting things in containers and microservices. So when we used to build applications, they were built as what we would call monoliths. So a big chunky application that had all the bits inside it, which was difficult to maintain. It was difficult to troubleshoot, and it was quite heavy going throughout the infrastructure it ran on. More recently, we've been using some stuff like containers and what we call microservices. And we're not going into application architecture here, but long story short, it's basically chopping up all the different functions in an application and making them run as their own little standalone service, and they just speak to each other in these what we call containers. Now, that's good for an efficiency perspective. It works better, it scales better in cloud. You have to have orchestrators to run the containers. The most prevalent one is Kubernetes, which has actually been out a long time now, that was created by Google back in the day. It's all open source though. Now, the reason I bring up container security is just because that changes a little bit what we have to look at, because the architecture has changed. So a container is basically its own little mini, so I don't want to say server because it's not, but everything it needs to run is within this little container. So in there's like an image, and there's runtime. So when the image is running, and traditional security tooling can't always look at containers properly. So just for the purposes of infrastructure, I just wanted to talk briefly about what a container was, and that you need different tooling to be able to look at the container itself and the orchestrator that's running all the different containers to build up the application, because not everything that we used to use in application security works for containers. More than that, we don't have time to go into it, but it is worth just mentioning. So, infrastructure security capabilities. These are the tools that we can use. Now, there's actually a few of them. First one is vulnerability management tools. Now, I have put a couple of examples down the bottom for these as well. Vulnerability management tools are basically tools that scan your infrastructure and tell you if it can find vulnerabilities. It's usually looking for if you haven't applied patches. So it will tell you, hey, you need to apply this patch here, because if you don't, you're vulnerable to blah. So it's a nice, because there's no way anyone could go through all their servers or their containers and do this manually. It's just not possible. So examples of vulnerability management tools are Defender for Cloud, which is the Microsoft one. There's a product called Nessus and Qualys, and essentially they scan your infrastructure and tell you what's wrong with it. They'll also tell you, they'll give you a report. They'll also tend to tell you how serious the vulnerability is, and help you prioritize which ones you should fix, and in what order, because sometimes you could end up, if you haven't done your patching very well, I mean, you could end up with hundreds of vulnerabilities, and where do you start? And some of these tools, I know Defender for Cloud, in some circumstances, it can actually apply the patches for you as well, but not for everything. It depends what it is. Then next up is Cloud CSPM, or Cloud Security Posture Management. So I talked about security posture management already, and this Cloud Security Posture Management tooling is basically a tool that helps you monitor your security posture, because again, it's completely impractical and never going to happen that that someone is going to be able to, you can't go through this manually. You need tools to go and look. So again, Cloud Security Posture Management, it will look at how your infrastructure is configured. It may be able to look at your applications as well, depending on how you build them. And it's constantly giving you reports on how to do on what your posture looks like and how you can improve it. Because if you think about cloud now, the reason this became more important in cloud is because before we had cloud, it was much easier to know what people were building in IT environments, because generally you had to ask someone to give you access to a server, and then you would have to do a change request and blah 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 blah. But one of the great things about cloud, but also one of the annoying things from a management perspective, is that anyone can log into the cloud and just spin up different tools because of the nature of how cloud is. And so it's really easy to really quickly lose sight of what's built in your environment, because people don't have to ask in the same way. Now, there are controls you can put in place to stop people doing this, but lots of people didn't when they first started using cloud, and people ended up with all these kinds of assets in their tenants, and they had no idea what they were doing, no idea what the security posture of them was. And that's why this security posture management in cloud, this tooling became way, way, way more important, because it was so much easier to spin things up in the cloud that people didn't know about. So examples of Cloud CSPM tools is Defender for Cloud. That's Microsoft's. Defender for Cloud does a couple of things. There's also a product called Sneak out there as well, which is also a CSPM tool. The great thing, this is not a plug for Defender for Cloud. Well, kind of is. If you're using Azure, then Defender for Cloud, the basic version is free, so you can just go in and use it. So you have no excuse not to have a look. And I've just gone back a slide. I'm not sure why. Then this is kind of it's kind of an evolution of CSPM. We're calling it CNAPP. So CNAPP stands for Cloud Native Application Protection Platform. Essentially, this is kind of CSPM with extra stuff added on. So when we talked about SIEM and XDR a couple of weeks ago, it's kind of like that, but for your infrastructure thing. CNAPP usually combines cloud security, posture management, and some threat protection and some other things. Basically, you'll see there's a trend in the security industry, and it makes sense that we're trying to put lots of different capabilities, like bundle them together rather than keep them siloed, and then we give things a new name. And the reason for that is that attackers don't work in silos, neither do we. So and well, neither should we. And so that's why this CNAP is basically sandwiching together some of these tools I was already talking about. So as it says there, CNAP includes container scanning, so vulnerability scanning, but specifically for containers, cloud security posture management, infrastructure as code scanning, which is basically vulnerability scanning just on infrastructure, cloud infrastructure, etc. So it's just scanning everything and telling you what's good, what's bad, what you should probably fix, because we can't do that manually. We just can't. Okay. Data security. Now, this one's become a big one recently. When I originally wrote this course, data security was not such a big thing. That's wrong. Data security has always been a big thing, but it's always come down quite low in IT environments and IT security priorities. But recently with AI, and I'll talk about this, and we do have a whole episode on AI coming up, so I won't talk about it too much, but AI has made data security way more top of mind, which is a good thing. So data security is we've talked about infrastructure, we've talked about applications. Data is, of course, the information, the stuff that actually is what we're trying to protect in security. This is what we're trying to protect and keep available, or keep. If we go back to our CIA triad, data is the thing we're trying to keep confidential. We're trying to keep its integrity, and we're trying to keep it available, because data is the thing that has the value. And by value, that can mean different things. I don't mean just an attacker is going to steal all my data and sell it, but it's the loss of data that, if we look at different kinds of attackers, people who make money, yeah, they might ransom you and sell it, or they might be able to resell it, or if they're nation states, they might be using it for espionage or something. But it's always, when attackers break into systems, what they're trying to get at is the data. That's what they're getting to. You can compromise a server, but you're only really compromising a server with the intention of getting to the data. It's always ultimately going to the data. So that's why data security is really important. But for many reasons, like if attackers get through all the other controls we have, our network controls, our infrastructure controls, our application controls, often our data is unprotected, apart from maybe some encryption. And that's bad. And data security, we actually have quite a lot of tools. Although, in fairness, maybe 5+ years ago and further back, data security tools were pretty rubbish. They weren't very good and didn't work very well. Whereas they've really come a long way in the last 5-ish years, and now really there's no excuse not to be using them. So when we talk about data security, there's different things we talk about. It's about like labeling data, also encrypting, as you would expect. Of course, it's about putting access on the data. You shouldn't have access to it if you don't need it for your job. Audit trails, etc. That's kind of what we're talking about. Now, again, I won't want to talk about this too much today, but one of the reasons data security is getting talked about a lot more recently is because of AI, because AI essentially is like a search engine across your environment. So if you have bad data security, AI will expose that really quickly. Because AI is really good at finding stuff. So it's not that the AI is creating a new problem. It's basically exposing an existing data security problem. And a lot of businesses are suddenly like, I want to use this AI in my environment, but I don't know what it's going to look at because I don't know enough about my data. So it's just highlighting existing problems in people's environments. So now data security is becoming more top of people's agenda, which is nice. So yeah, that's going to be, I think a lot of folks, we're going to see like a lot of people, I hope, up their data security game because they want to put AI into their environment. So first up, when you're doing data security, the first thing you have to do is classify your data, because if you don't know what your data is, if you haven't given it a label or classified it, then you can't protect it. So I'm sure at least some of you that are watching, you may have seen, especially if you're using M365 and other systems have something too. You have a label at the top that says like general or confidential. So, and I'm sure many of you have seen data labeling of some description somewhere. So generally, the first thing we have to do is classify data. So we might, and how we classify data will not be the same for every organization. Different organizations will do it in different ways, because what is confidential to one organization may not be confidential to another. And so each organization has to sit down and decide how they do their classifications. So for example, I might say, credit card numbers are confidential. And so they're sort of in that middling category. Obviously, also, you don't have to use these same categories that I've got on the screen here. This is just an example. Different, some businesses only have like 2 or 3 classifications, some have many. Again, it depends on the organization. But if you say, I think credit card numbers should be confidential, another organization might say, no, they are highly confidential. Now, credit card numbers should always be pretty confidential, but so that might be a bad example. But again, different organizations will have different standards and thoughts about how they need to classify data. So when you classify data, you have to make some guidelines saying, if this data has this in, it's this classification, and if this data has this in, it has this classification, etc. And then you have to decide, excuse me, you have to decide, when you've done that data classification, you need to just then decide what security controls you're going to put on. So obviously, as the data becomes more restricted, you would expect there are more security controls on it and fewer people can access it. So it is quite common sense, but until you've done that classification piece and decided how you think your data should be classified, you can't actually protect your data. And you'd be surprised how many organizations have not even done this piece, the data classification. Many organizations have not done it. It's sometimes quite shocking when you look at people's environments. So the other part of this is something called data lifecycle management. So we talk about classifying data and applying controls, but data lifecycle management is the process of getting rid of data when you don't need it. Now, I'm sure many of you are aware that, well, most jurisdictions have data protection policies. I mean, of course, the one that everyone knows is GDPR, the one in Europe, because it applies to all European citizens, and European citizens are everywhere. And essentially, this is about when an organization doesn't need data anymore, they need to get rid of it. And as I said, this isn't just for, your storage costs and things like that. It is actually in most jurisdictions nowadays a law that you mustn't keep data for longer than you need it. Otherwise, you can be subject to, problems or some kind of sanctions. So and that's difficult too, because how do you know when data is finished? It can be really hard. And again, before you even get to doing data lifecycle management, you have to decide what those policies are going to be. And again, many organizations have not done this. So it might be, hey, if a customer hasn't, let's just take e-commerce. If a customer hasn't ordered something with us in 2 years, we're going to delete their account. Just an example. But again, organizations have to decide based on like their business and the jurisdictions that they work in, like what makes sense for them. And then when you get to the end of the 2 years, like who's going to delete it? Like who's counting down? Now, there are actually tools that can help with that. But again, you've got to define what you want to do before you can start putting tooling in place, because it's completely unrealistic to expect that anyone is going to go through and delete the stuff manually. It won't happen. So again, this is important too. And also, of course, when we're talking about deleting data, it's also possible that if you don't get this right, you can delete stuff you need to keep as well. So, it's something that you need to sit down and think about. But I mean, I think most businesses, there's lots of reasons that data life cycle management is important, but let's face it, that, most organizations will be paying attention to the data protection stuff more than anything. But okay, so data loss prevention. Now, data loss prevention, it's also known as DLP. This is a technology that's been around for a while. As I said, the idea is it's controls that stop data being sent outside of an organization incorrectly. I have come across many DLP solutions in my time. The ones that were network-based, the old school ones, were pretty bad. They didn't work very well. I remember coming across a tool where the only thing, if you emailed a file out that was labeled, they would it would give you a warning and say, no, you can't do that. But all you had to do was zip the file up and then it couldn't recognize it. So historically, DLP tooling was a bit rubbish and was fairly easy to get around. Having said that, as I said, nowadays, modern DLP tooling is not network-based. It is kind of cloud and application-based. It's much smarter and much more difficult to get around. So another reason we see people not putting DLP in place is because historically they'll have been like, oh yeah, this was terrible. There was no point doing it. So that's another reason that people haven't used it recently. But again, I believe it will come back into its own. DLP is very smart now. It's not just about emails, of course, because that's not the only way you can take data out of an organization. You can take data out of an organization. You can take it on a USB. You can copy it to another something in the cloud. You can screenshot it. You can record it. You can print it. There's many, and DLP, modern DLP can cover all of those different things and block it if it's something that's not supposed to be moved. So it's got very, very good in the last few years. So, I mean, why is data security important? I've obviously kind of already covered this, but I mean, the obvious one being if you have a huge data breach, it looks bad for your company, your organization. Of course, with data protection regulations, you could be fined. And there's yeah, I mean, they're the main ones. It's basically your reputation. It's your reputation. It can obviously disrupt your business operations. Say if someone changed your data, it can destroy your competitive advantage as well if you leak a load of IP or a new project you're working on and your rivals get hold of it. So yeah, I mean, data security is really important, and it's shocking that we don't do it as much. Unfortunately, because money speaks in this world, usually businesses more pay attention to the possibly getting fined than anything. But there actually are way more negative things than anything else. Than just that. So it's important to bear in mind. Cool. So let's have a look at some of the capabilities. I've kind of already talked about them a bit, but so DLP, as I was saying, I've already talked about DLP a little bit, but DLP is the tooling that stops people accidentally taking things out of the boundary of the organization. So basically, the idea is with all data security, you give something a label, you classify it, and then based on that label, the DLP will look at it and say, okay, this file is allowed to be moved here, and here, and not here. So I'll give you an example, actually. I was playing around with Purview. Purview is the Microsoft data security thing, which is in the example there. And it actually sits in it's actually called Purview nowadays. I need to update that slide, not M365 DLP. But anyway, I was just making a demo about Purview, and I made a document. I made just a Word document, made it highly restricted. And I was just recording some things showing how I couldn't edit it and couldn't move it onto other things, and was recording it. I sent it to my colleague to review. Now, I forgot that when it's highly restricted, it also doesn't let you record the screen. So I sent my colleague I sent my colleague basically a black screen, because it didn't record, because DLP nowadays will even stop you recording a screen if it's got the controls on that say no screen recording, no screenshots. So all they could hear was me talking and they couldn't see a thing. So it wasn't super useful, though it was very funny. And luckily this was before the actual presentation, so it was fine. And we did the demo live in the end because we couldn't have the black screen. But yeah, DLP is great. So it's not just emails, it's sharing. It's also sharing. Nowadays, obviously in M365, you can share links. They can be shared externally. Again, DLP can block that too. Just because it's not, I don't, just to add to that, I'm going to go back actually. So the other thing, the kind of counterpart to DLP, and we'll talk about this more in the AI bit because it's more for that side of things. It's something called oversharing. Now, oversharing is the process of sharing data internally within an organization where it shouldn't be shared. Now, oversharing is a natural byproduct of collaboration. I'm sure if you're using M365 or anything similar, any modern productivity suite, you'll have shared multiple things even today. And oversharing is something that is it's kind of just a natural thing that happens, but it can end up with too many things being shared by too many people internally, and that can be a problem too. Because, for example, if someone had a spreadsheet with everyone's salaries on it and that gets overshared to me, I probably shouldn't see that if I'm not in HR. So it's a different problem that it doesn't cause like reputational damage and stuff in the same way because it's all internal, but oversharing can be a problem too. And now we have tooling, which I'll talk about later but I just thought I wanted to contrast the two because oversharing is not the same as DLP. So one is internal, one is external. Okay, so next one is insider risk management. So insider risk management is, and this one can be a little bit controversial. So an insider risk is someone who is in your organization who might do something bad. So there's a variety of reasons people do some bad things. It can be because they're upset with the company. They might have just got fired and they try and steal things, or they might be spying. There's multiple reasons that insider risk is a thing, and there's different ways we control it. It's when we do background checks on people before we hire them, and other things, but no one control is 100%. So insider risk management tooling is to do with looking at patterns of behavior, and people's profiles, and this is why can be controversial, because people have privacy concerns about it. But for example, generally insider risk management is quite anonymized. It's just basically looking at you as a person, and it's not looking at like every single thing you click on and every single thing that you do, like on your account. I mean, some of them can, I believe, but that's not really the point of insider risk management. It's about looking at like general behaviors that you do, and if your profile wildly deviates from that, and is doing sort of something that could look dodgy, that's when it would flag as an insider risk. So, for example, probably easier for me to explain with an example. I do not copy documents like externally, hardly ever, because I don't need to, and I'm also a security person. So if I had never copied like lots of documents anywhere, and then suddenly I am copying gigabytes and gigabytes of company documents to a USB or to like a Google Drive or an external online drive, that's unusual and could be me doing something I shouldn't be doing if that's not what I normally do. Now, it's also possible I might have just changed jobs, but insider risk management tooling looks for behaviors like that and sort of will flag a profile saying, hey, this person is like doing stuff that they don't normally do, and potentially it looks like it's dodgy. You should have a look and see what they're up to, because unfortunately it is a thing. But as it is a thing, and people do these things, and insider risk is a real thing. But of course, due to the nature of it sort of honing in on people's behavior, some people sort of feel like it's quite controversial. I'm not sure it really is, because it's looking at patterns of behavior rather than every single little click that you do, which I think is where some people misunderstand it. But we do sort of lump it under data security. And then you've got data retention tooling. So I talked about data lifecycle management. So data lifecycle management is when we look at when we get rid of data when it's no longer used. So there are tools out there that can help with this. They will look at the label. They'll look at the label that's been applied, and then will appropriately dispose of it when it hasn't been used, usually for a set period of time, and just get rid of it. Again, every organization has to decide how they want to do that, because it really depends on your industry and your jurisdiction. But there is tooling out there. In Microsoft, it all comes under Purview. Everything data security and data lifecycle retention comes under Purview. It's all in that product. But of course, there are other things out there as well. So, as I said, this one was going to be a little bit shorter. I still managed 40 minutes, which isn't bad. Everyone's been very quiet today. Hopefully that means I've explained it like super well. But I'll leave this up for a second and just wait to see if there are any questions folks have today. And if not, of course, then well, I'll thank you all for joining me anyway. It's been great as usual. And again, apologies for the technical issues last week. Next week, we're going to do 2 episodes to make up for that. So make sure you've got them both in your calendars. Yeah, it doesn't look like there's any questions coming in. I'll give it like another minute in case someone's typing, and I'll have a drink of my coffee. But if not, hopefully this has been interesting. Next week, we will do AI security, which is obviously a hot topic. And then we'll go back and do the episode that we didn't manage to do last week. So doesn't look like there's any more questions right now. So with that, I guess we'll wrap it up. Thanks a lot, everyone, for taking the time, and hopefully you've learned something. I will see you all next week.